And today we are going to solve this problem, which is called as frog jump. And the question is um, that a frog can jump from first step to nth stairs. Okay, and the frog has to reach the nth stair, and the height of the stair is given by the index. And if a frog jumps from ith to jth stairs, uh, it loses some energy, and the loss of energy is given by the absolute value uh, of the height difference at I minus 1 and j minus 1. So, so the frog, if he is at this ith index, he can jump from I plus 1 to I plus 2, right? So he can jump from like either one stair or two stairs. So you need to find the maximum, no, it's the minimum energy required for the frog to reach its destination. We'll also take an example. So if the array of height is containing this values like 10, 20, 30, and 10. So if the frog is at, let's say, first stair, and he has to reach this last stair, so what are the possible ways? It can jump from 10 to 20, right? Then take a two jump. That's one. It can then come to 10 to 20 and then take another one jump and then another one jump. So we need to calculate the energy which is being spent at each step. And if we have a close look at the various options, then we basically get an idea that it is going to be like, first he needs to jump from 1 to 10, I mean like 1 to 2, and then from 2 he needs to reach 4, right? So in that case his energy loss would be like 10 over here, and from 20 to 10 another 10, so a total of 20. So that's the minimum energy required for the frog to reach from first to nth stair.
Into the solution of this, we are going to solve in Java. So first let's declare the main class itself, and let's do this first by recursion, and then we'll see if we can further optimize it. Fine. So let's say I have a class frog jump, and what I need to do is I need to get the minimum value, right? So minimum energy, let's call this as result, like we get from this min energy, right? Min energy function, which is going to take the index from which we are going to start, right? So first let's have the value of number of steps. Let's say we'll take the example given in our question. So let's say it was having 5 as the value, right? Let me check the question there. So it is 4, okay, and we'll take this array only. So let me copy this. So it is 4, right, and value 4, and we have an array, right, which is going to be called as height in our function, but let's keep it like this over here. So yeah, 10, 20, something like 30 over here, and then 10, right? Cool. So it is going to take the n, which is the size of the array, and the array itself, right? And we also need to like make sure that the function which we are creating is returning as the value in int, as we are going to save it. So yeah, let's fix this, create this method. It's just private over here, right? So what do we need to do? We need to solve this recursively. Let's say this method minimum energy calls a function over here, right? uh, it basically returns a function which is going to be called recursively. So let's call this as recursion rec function, something like this, right? We pass the array, we pass the n value here, right? Cool. So this will, so what could be the base case if I ask you what is the base case? So for base case, it would be like if my index, right? If my, let me call this as index over here, and let me call this as height. So if my index equals 0, I should return 0, right? Because what it means at as 0 over here is basically the very first step, right? If it is at 10th, it does not require any energy to spend, right? It is already at the destination, right? Now we need to find if the frog is jumping one step, right? So if I call it like int first step fs, right, equals to recursion function and index plus 1, right? Also it should be -1, and then we have the height, right? And what else? We need to add the absolute, right? So math.abs function we can use, right? Absolute of what? We need to find the absolute of height of I minus height of I minus 1, right? This is what is given in the question, as that is what it is. So instead of I, we need to place the index itself, right? Because we are at index. So that is what we get at the first step. Now what about the second step? So before calling the second step, we should be clear as to what we are exactly doing. So for the first step, we took one step, right? And you can see here, for the second step, we are planning to take 2 steps, right? And the same thing over here, only with little difference. We will be finding the difference between height at index and height at index -2 and the absolute value, right? Just need to take care over here that whenever this right is getting called, right, or the first step is getting called, uh, we should be clear with another scenario, right? If the index is less than or equal to 1, in this case it will get a null pointer here. So to handle that particular scenario, we need to have a check here, right? That is, if index is greater than 1, right? Then only we need to call the second step, right? Cool. So we have handled that scenario as well. Now we have this recursion call for the first index, if I take it in that way, and then we are going for the second step, right? What do we return? So we need to find the minimum, right? So we return the minimum. mean of what? Yeah, first and second step. Once we get that, what are we expecting over here? We are expecting an output, right? Output which will basically tell me uh, the value of the minimum energy, right? And if we run this, what are we getting? So we are getting an error at line number 17, right? And what are we getting over here? We are getting that it is out of bound. Okay, so we need to check. So array is like this many values, right? At 17 only, right? So okay, okay, so I think we should keep it as 3 because we are already following a zero based index, right? So that was an issue. Let's run this again. Yeah, we got this answer as 20. So this is a recursive way, right? And if we further solve this and think about a dynamic way of doing it, so I'll try to do that as well. So for dynamic, what we do is mostly we create like a array where we save the values, right? And that is what we are going to do over here. Of size n only, right? We are following a zero base, so that is fine. We can have n plus 1 because we will be following zero base index, right? So right, fine. Let's fill this. Okay, I think I took the wrong function here. Right, that's been done. What we can do over here, we need to pass this dynamic uh, variable which we created here, and the function also we need to add it here. So I think it should be everywhere, right? Fine. So what is the most common thing which we do before calling anything? We check, right? If dp at index is not equals to -1, we just return that, right? That is the whole idea. So right, what else? So we also save the value, right? We save the value of whatever we get in dp and then return it, right? So what we'll do is, right, we'll make this as db of index value to be equal to the minimum of this, right? And we return that. Anything else we need to do? I don't think so. What will this do is basically make my whole recursive question solved in dynamic way. So let's see if we get that. Yeah, we get this the answer to be 20, right? So with just minimum changes we are able to solve this question dynamically. There are other approach as well, tabulation, right? um, but I will be covering that in the next video. And in the next video I'll also talk about how to basically do a space optimization. That is something which can give a very good impact on interviewer if you're giving an interview. So yeah, please check my next video as well. So yeah, do like my videos if you're following my videos at regular time, and do comment if you need any specific question to be solved. Would be happy to help. So yeah, do subscribe my channel. Thank you.